All right, so we're going to be finding sides in right triangles using the primary three trigonometric functions. And you can see the definitions over here. If x is an acute angle, meaning this angle or this angle, one of the two small angles in a right triangle, then the sine of x, students want to say sin x, but it's pronounced sine of x, equals the ratio of opposite side length to hypotenuse length. Opposite over hypotenuse. It's not cos x, it's called pronounced the cosine of x. We write it like this, but we say it like this. The cosine of x is the ratio of the adjacent side to the hypotenuse. We're talking about side lengths here. The tangent of x. Tan x is the abbreviation. Tangent of x is how we say it. Equals the length of the opposite side divided by the length of the adjacent. Tangent is opposite over adjacent. All right, and it looks like, there we go. Okay, so I've got two right triangles. We're going to do two examples here and then two more. I want to find how long is x, and I'm going to be using the 20-degree angle. All right, so I've got to determine what do the 16 and the x represent. So first of all, across from the right angle is always your hypotenuse. All right, and you'll see this 20-degree angle, it touches two sides. It touches the hypotenuse and it touches another side, which happens to be x. The other side that the angle touches is called the adjacent side. It's next to the 20 degrees. The word adjacent means next to. Across from the 20 degrees, way across here, the furthest side away from the 20 degrees is called the opposite. All right, let's do the same thing down here. I'm going to choose to use the 28-degree angle to find x. Now, I do happen to know that down on the bottom, this bottom angle is 62 degrees, and I could choose to use that, but I'm going to be straightforward and use the 28-degree angle. All right, this 28-degree angle touches two sides. The one across from the right angle is the hypotenuse, and then the other side that the 28 degrees touches is the 9, and that's my adjacent. It's next to the 28 degrees. Across from that 28 degrees is x. That's my opposite side. All right, that's my first step. Identify what the sides' names are with respect to the 20-degree angle. The hypotenuse is an absolute term. The hypotenuse is the hypotenuse, but opposite and adjacent depend on where you're standing. If I'm standing up here, now x is across from me. X is the opposite. But if I'm standing here, the blank side is my opposite. So with respect to the 20 degrees, that blank side is the opposite and x is the adjacent. So anyways, to find x on the top triangle, I want to involve the hypotenuse and the adjacent. I need to involve the adjacent because I need to find x, and involving the opposite does me no good because I don't know how long it is. But I do know the length of the hypotenuse, so I want to involve hypotenuse. Which trig function uses adjacent and hypotenuse? Cosine involves just the adjacent and the hypotenuse. So I'm going to set up a cosine equation, and it's always cosine of the angle, cosine of 20 degrees, equals, you've got to pay attention to the definition, adjacent has to be on top and hypotenuse has to be on the bottom. So for me, x is on top, 16 is on the bottom. Let's take the same step down here. I don't care about the hypotenuse in this one. All right, I don't have an x there and I don't know the length of it, so I can't, it doesn't do me any good to involve the hypotenuse in an equation because I have no information about it. But I do want to involve x, which is the opposite side, and I do want to involve the adjacent because I know the length. Which trig function involves just the opposite and the adjacent? Well, here we go. It's tangent. So I'm going to set up a tangent equation. Tangent of the angle, tangent of 28 degrees equals opposite divided by adjacent. All right. These two problems are my easiest possible case because they both have x on top of the fraction. When x is on top of the fraction, I can finish solving this in one step. To get x by itself, all I have to do is multiply both sides of this equation by 16. X divided by 16 times 16 leaves me just x. 16 times the cosine of 20 degrees equals x. I take a scientific calculator with a cosine button. I make sure it's set to degrees. Your calculator is going to have a mode button where you can set the mode to degrees or radians. We want to be in degrees when we're solving triangles. I've never seen anybody label a triangle with angles in radians. So into the nearest tenth of a unit, x is about 15.0, 15.03508.193. All right. Let's do the same thing down here. To get x by itself, all I have to do is cancel out the fraction, multiply by the denominator. The denominator is what makes a fraction a fraction. The division is what makes a fraction. So we undo division with multiplication. X is now by itself. X equals 9 times the tangent of 28 degrees. And that's about 4.785. Following the rules of rounding, we're going to call that 4.8 to the nearest tenth. So this is how it looks when x ends up on top of the fraction. Let's do two examples now where x ends up on the bottom of the fraction. All right. Same first step. I'm going to identify which angle I'm going to use. I'm going to use the 62-degree angle. And it touches the x and the blank side. X is across from the right angle, so x is the hypotenuse. And the other side that the 62-degree angle touches is the adjacent. And I really don't care about adjacent here because I don't have a number or a variable there. Across from the 62-degree angle, the furthest side away from that 62 degrees, that's when you're looking at the opposite. It's when you're as far away from that angle as you can be. That's your opposite side. So I want to pick a trig function that involves the opposite and the hypotenuse. That's sine. I want to write a sine equation. Sine of the angle equals opposite divided by hypotenuse. Let's just go down here and do the same thing. My 35-degree angle touches two sides. It touches the x and the blank side. The blank side is across from the 90-degree angle, so the blank side is my hypotenuse, and that means the x is my adjacent. The furthest side away from me, the one across from me, is my opposite side. The 14 is my opposite. And here, the hypotenuse is useless to me in finding x because I need a length in order to find x. So I'm going to involve the opposite and the adjacent, and that means here's another one where I'm using tangent. So I write tangent of, and it's always sine or cosine or tangent of the angles. Angles go into trig functions, ratios come out. Opposite goes on top in this ratio, adjacent goes on the bottom. So the 14 has to be on top and the x has to be on the bottom. All right? When x is on the bottom, it's just an extra step. Is it hard? No. Is it an extra step? Yes, it is. But the first step looks just like the first step in the previous example. So you'll notice the first thing we did was cancel out the fraction. Whatever's on the denominator, we multiply both sides by that. And in these problems, that got x by itself. It's still what I do here. I cancel out the fraction. I multiply both sides by the denominator. But here, this did not get x by itself. It just moved x to the other side of the equation and got it in front of the sign of 62. So what would get x by itself now? Getting rid of the sign of 62. And we're joined together with multiplication. I have x times the sign of 62. So I'm going to divide by the sign of 62 on both sides. And that gets x by itself. Now I've got x equals 23 divided by the sine of 62 degrees. And probably it's a good habit to write the units here. And I pick up a calculator, 23 divided by, hit the sign button, type in 62. You should get 26.049, which rounds to 26.0. Let's repeat those steps, see if you remember. First step, cancel out your denominator. Multiply both sides by whatever's on the bottom of that fraction. This does not get x by itself. It just moves x to the left side of the equation. And now it's with the tangent of 35. And it's joined by multiplication. So I divide by the tangent of 35 to break the x free. We liberate the x, and now we know what's the value of x. X equals 14 divided by the tangent of 35. And to the nearest tenth, it's 19.99, which would round up to 20.0 if we're following the traditional rules of rounding. All right, so to make a long story short, if x is on the top of your fraction, when you set up your first equation, you'll find that the answer, the solution for x is going to be the number times the trig function. X is on top, it's the number times the trig function. When x is on the bottom, your solution is the number divided by the trig function. X is on the bottom, it's the number divided by the tangent of 35. That's the story. Good luck on these.